Some of these involve some of the log rules that we don't like to use. Some of these involve simplifying logs in the process. Others are that lovely switch it into log form, but it doesn't turn out nice, you know, other good stuff. So we're just going to go through about 6 of these, and then we'll do some practice together or test correction time, and we'll be done. Okay? All right, so in question 1, when I look at something like that, we're in log forms. Okay, so what do I have to do to simplify here? First thing is move the 2. Okay, so if you see numbers in front of any of the logs that you can't divide, you should always move those back as an exponent first. Okay? Second thing would be to simplify logs. Okay? Which logs in this can I simplify? The ones on the right-hand side. And the ones on the right-hand side are being added, which means what can we do? Multiply. So I've got log base A of x is equal to log base A of what? 45. Then what are we allowed to do with the logs? Well, what's 3 squared? 9. 9 times 5. 45?
I did 2 cubed.
Oh, yeah, that's split. All right, so then what are we allowed to do with the log base A's?
Cancel.
Cancel. Which then leaves us what? X equals 45. Good. So sometimes we have some condensing to do, even if it's a weird log base. That's okay. That just completely canceled for us. Let's take a look at 2. What can we do to simplify in question 2 before we get started?
3 minus 2.
Yes. Those ones, okay, I'm going to kind of show 2 different ways on this one, just so that you can see. The preferred and easiest method is log base 3 of 9 is 2. Now, for those of you that are like, I'm not going to see that. What other way could you look at that?
3 to x power equals 9.
Well, you could do that, but I'm just saying between the 2 logs is a plus sign. What does that mean I could do? Multiply. So you could also make that log base 3 of 9x plus 18. Now, is that wrong? Absolutely not. There are times that is going to give you some bigger numbers than what you see here, and it could be bad to do. So sometimes recognizing the simplified log over here is much better and easier, but I just want to show you that it is possible to do both ways. So if I continued with either one of these, I don't know. Let's go back to the other one over here. If I had put that together, the 9 with that, and distributed, where would I go next? I would go into exponential form. So what would that say?
9.
Nope. 3 to the third, which is what? 27 is equal to 9x plus 18. So then I would solve this by subtracting 18 from both sides and dividing. With logs, we typically check our answers to make sure we're not taking the log of a negative number. Would 1 be okay? Yes. Now let's say we did it the other way. Okay? What would I do on the other way to solve? Subtract 2. So that gives me log base 3 of x plus 2 is equal to 1. Then what?
3 to the power of 1 equals x.
3 to the first equals x plus 2. Subtract 2 from both sides, and I still get 1. So you're going to get the same answer whichever way you do it if you use your log rules correctly. However, sometimes one could be easier than the other. Okay? So either way is possible. Questions on that? Good. All right. Now, we've talked about some of them like number 3 already. What kind of question is number 3? Yeah, decimal bases. Okay, this is an exponential function. Can I get a common base? No. So what's my other option to solve? Log form. All right, so let's get started on that together. If I switch this into log form, what's it going to look like?
Log base
Of 2 the
2 minus
is equal to.
x 1 plus x.
Okay. So this is that nasty kind. Yes? That we've done a couple of today already. What do we do next in this not so nice kind? Yep. I bring the 2 minus x to the front. And And often, to save myself some room, I'll just bring it out front and put it in parentheses and just kind of scratch it out back here. So where would we go next from here? Anyone remember?
Oh, you distribute.
We distribute. All right, see if you can finish this one out from here. All right, so we feel better about that kind at this point? Do we feel like we're getting better at those? Yes. There won't be you can't expect me to do 10 of those questions because number one, I don't want to grade 10 of those questions. Number two, there's other things I need to test. So one, maybe two, I don't know. Maybe two sounds like a lot. All right, let's look at 4. 4 has something weird in it too. I just decided to do all the weird questions in one day. How about that? What is different about 4? Absolute value. Well, we know how to do those anyway, and this is a good review for our exam. So let's just talk about that. Okay? So what do I do to start with since it's a log?
You make it
3
exponential.
seconds goes.
Exponential form goes like this. So that would be 3 to the second power equals what? Absolute value of x plus 4. How do you handle absolute values?
Do 9 and then negative 9.
You do 2 different answers, right? So you say x plus 4 is equal to what?
9.
Or
X
x plus 4 is equal to negative 9. Solve that one. Take a minute. What do we get? We get x equals negative 13 or x equals 5. Now remember with logs, we always check our answers, right? Is negative 13 a problem here? No. Why not?
It would be negative 9, but absolute value.
Right. Because when I plug it in here, it's within the absolute value. It would, within the absolute value, give me negative 9, but the absolute value of that would make it positive before I take the log. So that's okay. Okay, so there are places that negative answers are okay, but we should check our answers.
So you can't have
You cannot take the log of a negative number or 0. So if you go back and plug your answer into the log and you're taking the log of a negative number, not if the answer for x is negative. If when you plug it in, you're taking the log of a negative.
Is the base able to be negative?
No.
Okay.
So if the base is an x, that will immediately throw things off too. All right, last 2 of these. Okay, where did we see something like 5 before? On our homework. Okay, so now that we recognize this, e to the 2x, e to the x, and 4, take a minute and try to factor this the way we factored it on our homework. So we said we split this up. What would go first in each of these parentheses? E to the x. All right, see if you can finish it out from here.
Minus 4, minus 1.
All right, so we have e to the x minus 4, e to the x minus 1. What do we do from here? Set them each equal to 0. So that becomes e to the x equals 4. E to the x equals 1. Are we done yet? Almost, but we still have to solve for x, right? So that's switching into log form from here. So log base e is ln of 4 is equal to x. ln of is equal to. Now, one tricky thing on this one is this. It's not really tricky. What is the ln of 1? 0. So if you can do that, you should. If either of those were negative and you got ln of a negative number, what would that mean?
No.
That would not be a solution. It doesn't mean the whole thing is no solution, but let's just say that was like ln of negative 1, just for argument's sake. That would just mean that answer would go away and you'd just keep the other one. And that's okay. Perfectly possible. Okay? Now in the mode of factoring, let's look at one other one like that. And then I may just have you start a few homework questions for practice. In question 6. This one looks very interesting. Yes? Okay? What, in terms of factoring, might stick out to you in this question? What do we always look for? Ooh, I heard someone say it. Common factor, yeah. Yep, this has a greatest common factor. What is the greatest common factor? E to the x. If I pull that out, what am I going to be left with? X squared minus 3. What do you do once you pull out these factors? Yep. We say e to the x equals 0. And we say x squared minus 3 equals 0. And we solve both. Now, one of them is solved by switching into log form, right? Because how do I fix the e to the x equals 0? We just switch and we say ln of is equal to x. Are you allowed to take the log of 0? No, you are not. So what do I do with that? Cross it out. How do I solve the other one? Add 3 to both sides and square root. And we don't forget plus or minus. Do I have to check my answers on that one? No. Because what's the original equation? It's an e. It's an exponential, yeah? You don't have to check the exponential ones. You only have to check the log ones. Remember the exponentials, you could have all real numbers for your domain. For logs, you can't, yeah? All right. We have 30 minutes, and I feel like I'd like to give you test correction time because we did not have it, and I know like this week is coming up, and the next week is like a lot of things, yes? So I think let's use our class time wisely, okay?